Welcome to the Backyard Professor videos. I've just recently had a wonderful opportunity to discuss some ideas on evolution with some friends of mine, and the idea came up that as we were talking it out and comparing evolution to creationism and so on and so forth, we come across this idea that we shouldn't take evolution seriously because it's only a theory. I mean, it's all guesswork. We weren't there 600 million years ago, and we have not been able to see it for ourselves. And I was explaining to him the importance of thinking through things for themselves instead of just relying on authorities. And yet they said, well, don't you do that with evolution, because all the evolutionists only live to be about 70 to 80 years too. And this is an interesting thing. So I did some scratching around in some of my writings, and I think it's important to understand how a theory and a hypothesis and facts go together. Now, two LDS evolutionist scientists in their book Evolution and Mormonism, A Quest for Understanding, Trent D. Stephens and Dr. Jeffrey Meldrum, has written about the relationship between some of the Mormon doctrines and evolution. This is 2001 by Signature Books. They describe how science is empirical. It's based on observation. Its strength lies in its being founded on the collection of observable, reproducible facts or data. And they say this you can't do with evolution because, of course, we didn't live back then. We didn't see that. So therefore, evolution is just a theory. I might add none of us were around when God created the universe either, so that's not an observable fact either. So, you know, where are you stuck at, right? Well, one scientist or group of scientists can report an observation or the results of an experiment, and other scientists can replicate the same observation or perform the same experiment to see if they obtain the same results. This is why cold fusion, about a decade or so ago, when they announced down in Utah that they had discovered cold fusion, rather than being simply accepted on authority because some scientists said so, other scientists were so electrified about this that everyone else jumped on the bandwagon and began to do their own experiments, and thus they discovered the flaw of the cold fusion idea. This is how it should work. We want to obtain predictable results. In the case of an important theory, such as evolution, this process of replication and verification can be repeated thousands of times. Now, this is important to understand the context here. The word experiment and experience share the common Latin root, meaning to try something out. One of the beauties of science is that virtually anyone can try out the experiment. They can challenge the current conclusions or theories by designing a particular experiment to test a new hypothesis. On the other hand, it is of no scientific merit for someone to advance or challenge a hypothesis or a theory without presenting reproducible data. This is what makes science so powerful. We all get to be involved. It is a completely democratic process. Everybody can do science. It is important for anyone considering science to understand the difference between a fact, a hypothesis, a law, and a theory, as each of these apply in science. A fact, or a datum, is a truth that has been established by experience or observation. For instance, the tree behind me, this quakey asp. Quakies always have the white skin like that with the black marks, and they're somewhat relatively tall, and at the top of them they have their leaves. That's my observation of the quakey behind me in this video. If you wanted to test the theory that all quakies look like this in a general sense and that they're deciduous, That is, they shed their leaves every year, and so on and so forth, as opposed to the pine trees that keep their pine needles. You too can make observations, and it doesn't matter what country you're in. You can check this out for yourself. This is how we know quakies are deciduous. We look at them in the fall and they shed their leaves. They're the ones that turn the beautiful yellow, red, and blues and all that, the gorgeous colors. So, a hypothesis is a proposed explanation. I just gave you a hypothesis of the quakey behind me. For some phenomena, an attempt to make sense of the data, which usually is advanced provisionally so that it can be tested. I've given you a hypothesis. Quakies are deciduous, right? So now we can test that. A law is a statement of a relationship or phenomena that consistently occurs under a given set of conditions. So I would propose as a law for quakies being deciduous that every single fall in the year, wherever you are, their leaves will turn colors and they will shed their leaves, right? And now we all can observe that to see if that is indeed what happens. Is the quakey an evergreen, or is it a tree that sheds its leaves each year? You don't have to take my word for it. You can find out for yourselves. This is the power of science. This is what makes science self-correcting. I mean, I'm probably stating the obvious to a lot of you, but there's a lot of people who still don't understand how this works. So, and examples of this, of course, include the laws of motion, the laws of thermodynamics, the law of gravity, the law of definite composition in chemistry, the law of partial pressures, and the law of independent assortment in genetics. A theory, according to Webster's dictionary, in scientific terms, is a coherent group of explanations for a related group of phenomena. Many people have the mistaken notion that given enough time and evidence, a theory will eventually become a law. That is not how it works. Now get this, this is important. A law describes a single phenomenon, whereas a theory explains a group of related phenomena, each of which may be described by a law. Examples include the theory of relativity, the theory of quantum mechanics, which incorporates the law of gravity, the cell theory, the nuclear theory, and the theory of evolution. Webster's dictionary also presents a non-scientific definition of a theory as a guess or a conjecture. It is unfortunate that this one term, theory, has two very different definitions. One is a coherent group of explanations. That is what a theory is. The other is a guess. This situation has led to many misconceptions about the strength of various scientific propositions, especially concerning the theory of evolution. It is common for scientists and non-scientists alike, of course, when speaking of non-scientific issues, to state, well, I have a theory about that, I have a theory about this quakey being a deciduous tree. I have a theory. This year, no quakies will shed their leaves. That's my theory. It's a guess. However, in this context, a theory often means an unstated educated guess or explanation about some event which may be trivial. As a result, many individuals have trivialized well-documented, well-founded unifying principles such as evolution by the casual retort, oh, it's only a theory. The difference between a theory and a fact can be demonstrated in the following examples. And he says the most time-honored fact in our society is that the sun rises every morning. In fact, there it is. It's just coming out of the clouds and shining on my lovely face. Beautiful man, huh? Given the provision that the sun only appears to rise as the earth rotates, we can state as a fact that the sun apparently Rose this morning. There she is. Because that phenomena can be observed by any number of people. However, when we add the term every morning and state that the sun rises every morning, the concept becomes a theory, a prediction, as it were, because there is no way that we can observe every morning forever. See how that works? That's interesting, isn't it? Another example is the cell theory, which states that all living things are composed of cells. Now, I'm a living thing, and I'm composed of cells. This tree behind me, this is not the same kind of living thing as I am, but it is a living thing, and it is composed of cells. The lovely vegetation around here, with all of the various berry bushes in the mountains and shrubs and scrubs and sagebrush, etc. It's the same thing with them. Even though they're a different kind of life, they also are composed of cells. This is what the cell theory says. This is not a statement of fact. It is a theory. Consider, we can look at specific tissue and observe for a fact that the tissue is composed of cells. But without looking at every tissue from every living thing, we cannot state as a fact that they are all made of cells. The cell theory predicts that any tissue a person observes is composed of cells. The long-term test is to continually determine if the predictions of a theory are borne out by the facts. So far as we can tell, the cell theory is absolute fact. No one has ever observed it otherwise. But it's still a theory, but it has billions of observations of all kinds of living things, whether they're animal, vegetable, human, etc. And so far, it has never failed a test yet. So the cell theory is a fact. Whenever an observation or experiment reveals a fact that is not consistent with the prediction of the theory, and if that observation can be repeated, for instance, if someone found a living thing that did not compose of cells, and then someone else verified that, then the theory must be modified to accommodate the new fact, or else be replaced by a new theory. This is beautifully sensible. Now here's the kicker, and this is by the two LDS scholars, Meldrum and Stephens. Unlike science, which is based on repeatable observation, religion is based on faith, feelings, and subjective experience. Because of this difference, there is a tendency for some people to accept science and dismiss religion, whereas other people accept religion and dismiss science. This conflict is beautifully depicted in the movie Contact by Carl Sagan, as you know. One of the greatest sources of conflict between science and religion is the concept that seeing is believing. Those who embrace science and reject religion are often of the opinion that if I can't see it, then it must not exist. If we examine the process of seeing, it quickly becomes apparent that relying on our visual senses alone may not be all that it's cracked up to be. There are limitations to what we can see. This is why we propose various observations. If I was to make an observation that I truly did claim that the bark of a quaking asp tree was bright blue, if no one else observed that, then we can't verify a new fact about the tree, you see. So this is an interesting idea. This helps us see the relationship. If evolution is only a theory, that is all it has to be, because it has had observations by hundreds of millions of scientists around the world, and every experiment so far that we're aware of has come to the conclusion that evolution is occurring. Now, how it's occurring is constantly being fine-tuned, of course. But if an evolutionist A, such as Gould, Stephen Jay Gould, the Harvard evolutionist, describes, because of the data he's collected, that evolution works by punctuated equilibrium, and evolutionist B, say Dawkins, Richard Dawkins, says no, it's not punctuated equilibrium, it's this manner or whatever. There are various competing ideas on how evolution works through time, but that's not questioning that evolution has been observed, understood, and seen. Now, the great science and science fiction writer Isaac Asimov, in his book, X Stands for Unknown, in his chapter on the Armies of the Night on page 213 and 214, has said this: a theory, when advanced by a competent scientist, is an elaborate and detailed attempt to account for a series of otherwise disconnected and apparently unrelated observations. It is based on numerous observations, close reasoning, and, where appropriate, careful mathematical deduction. To be successful, a theory must be confirmed by other scientists through numerous additional observations and tests, and where this is possible, they must offer predictions that can be tested and confirmed. The theory can be and is refined and improved as more and better observations are made. Now, this is a classic, beautiful, easy to understand description of how science works. Here are a few examples of successful theories and the dates upon which each was first advanced. The atomic theory was advanced in 1803. It has absolutely been observed millions of times and completely confirmed, but they call it the atomic theory. The theory of evolution, 1859. The quantum theory in 1900. The theory of relativity in 1905. Each one of these have been endlessly tested and checked since they were first advanced as a theory, and with the necessary improvements and refinements has passed all the challenges. Michael Dowd, in his book, Thank God for Evolution, is a very enthusiastic, televised evangelical Christian, and he quotes approvingly of many, many scientist evolutionists, and he says evolution absolutely has happened. He knows evolution has become a fact. Now, it's interesting on page 78 how he says this. Less than 200 years ago, when Darwin proposed that the complexity and diversity of life on Earth were not the result of supernatural and instantaneous creation, the proposal of evolution was just a theory. An outlandishly scandalous theory at that, and you can read all about it in Stephen Jay Gould's book, Ever Since Darwin. It's really a good read. It's fun. Today, that life on Earth came into being over a vast span of time, and that complex forms exist and emerged from simpler forms is a fact. You may or may not feel comfortable with calling this biological history of Earth on Earth evolution. To be sure, our scientific understanding of the causes of biological evolution change is still very much in the discovery phase, witnessing the fascinating new science of evolutionary development. Nevertheless, Darwin's theory that life emerged over a long history and by means internal to natural Earth processes has now become a fact. And he discusses several different scientists on page 78, 79, and 80. In the American vernacular, theory often means an imperfect fact, part of a hierarchy of confidence running downhill from fact to theory to hypothesis to guess. Thus, creationists can and do argue evolution is only a theory, and intense debate now rages about many aspects of the theory of evolution. If evolution is less than a fact, and scientists can't even make up their mind about the theory, then what confidence can we have in it? See, this is the creationist approach to it. Well, evolution is a theory, and it is also a fact. And facts and theories are different things. They're not rungs in a hierarchy of increasing certainty. Facts are the world's data. Theories are structures of ideas that explain and interpret the facts. Facts do not go away when scientists debate rival theories for explaining them. Einstein's theory of gravitation replaced Newton's, but apples do not suspend themselves in mid-air pending the outcome. And human beings evolved from ape-like ancestors, whether they did so by Darwin's proposed mechanism or by some other means yet to be discovered. Evolutionists have been very clear about this distinction between fact and theory from the very beginning, if only because we have always acknowledged how far we are from completely understanding the mechanism, the theory, by which evolution, the fact, occurred. Darwin continually emphasized the difference between his two great and separate accomplishments, establishing the fact of evolution and proposing a theory, natural selection, to explain the mechanism of evolution. He's quoting Stephen Jay Gould there. Today, nearly all biologists acknowledge that evolution is a fact. The term theory is no longer appropriate except when referring to the various models that attempt to explain how life evolves. It is important to understand that the current question about how life evolves in no way implies any disagreement over the fact of evolution. That's Neil A. Campbell. Biology without evolution is like physics without gravity, according to Sean B. Carroll. So this idea that evolution is only a theory is completely false. Evolution is a fact. How it happened, we do have various theories of discussing the various ways it works. And there may not be one single way either. And finally, Douglas Futuyma, in his absolutely magisterial book, Evolutionary Biology. This was published in 1998. It's a college textbook. People often speak of a mere hypothesis. This is on page 11. As in, it is merely a hypothesis that smoking causes cancer, as if it were an opinion that is unsupported by evidence. This hypothesis idea. In science, however, a hypothesis is an informed statement of what might be true. It may be poorly supported, and especially when it's first presented, of course, but as we've seen, it can gain support to the point to where it is effectively a fact. For Copernicus, the revolution of the Earth around the Sun was a hypothesis with modest support. For us, it is a hypothesis with strong support. Likewise, a theory in science is not an unsupported speculation. Rather, a theory is a mature, coherent body of interconnected statements based on reasoning and evidence that explains a variety of observations. Or to quote the Oxford English Dictionary, a theory is a scheme or a system of ideas and statements held as an explanation to account for a group of facts or phenomena. A hypothesis that has been confirmed or established by the observations or an experiment or 2 or 20 or 50 or 1,000 or 1,000,000 and is propounded or accepted as accounting for the known facts. A statement of what are known to be general laws, principles, or causes of something known or observed. So atomic theory and quantum theory and the theory of plate tectonics, these are not mere speculations or opinions, nor are they even well-supported hypotheses, such as the hypothesis that smoking causes cancer. Each is an elaborate scheme of interconnected ideas. And all of these interconnected ideas are strongly supported by evidence that accounts for a great variety of phenomena. See how that works? Because a theory is a complexity of statements, it usually does not stand or fall on a single critical test, as some simple hypotheses often do. Rather, theories evolve as they are confronted with new phenomena or observations. Parts of the theories are discarded, they're modified, or else they're added to. But that doesn't refute the theory, it refines the theory. Interesting how that works, isn't it? So this is the idea. It is an ongoing process. There isn't just a once and for all theory to give us all knowledge. No, that's not true at all. So I hope in the process, when you discuss the implications and the importance of the relationship of science and observation, or the idea of presenting a theory in order to test it. You know, if we have a theory, when I drop a rock, it falls sideways, and it flies off sideways. You know, you're going to have a lot of people testing that assumption, that theory, to confirm it or refute it. We know, thanks to the law of gravity, which is the theory of gravitation. Now, the reason it's a theory of gravitation is we're still trying to discover what it is, believe it or not. Is there such a thing as a small, very small, ultra subatomic particle called the graviton? That's been one of the theories. Has it been observed? Is it confirmed or refuted? But in the process, the theory of gravity still remains. When you drop a rock, it goes straight down to the ground in relation to you and the center of the earth. Right? It's the exact same thing with the theory of evolution. The fact of evolution is extremely strong these days. And it's wonderful that it's being discussed. Absolutely. This is the idea of science. See, in science, there is no hierarchy of authority with which someone has to defer to give you the truth based on a feeling in your heart, or because God's mystery has been revealed to us and we give it to you, and you must simply believe and obey what we say. No, that's religion. Science says everybody gets to get into the act and everybody gets to perform the experiments to see for yourselves. And it openly expects feedback. That is how we grow and learn in knowledge. And it's a great thing. So, thanks for watching my Backyard Professor videos. I hope you have a great day. I will see you in the next video. And furthermore, besides just a great day, have a great informed life.